Welcome everyone, and thank you for joining today's webinar titled From Pandas to Koalas, Reducing Time to Insight for Virgin Hyperloop Data with Patrick Olenyuk and Ifan Chow. My name is Cyrielle Simeon and I will be your moderator for today. Just before we get started with our presentation, I just wanted to go over some logistics to ensure we have the best possible experience. First, your audio connections will be muted for the entire webinar so we can hear you. This webinar is recorded and available on Databricks.com, along with the code samples and notebooks to help you get started. So if you have any colleagues who aren't able to make it, you can share the link for them to watch the replay. If you have questions, please submit them via the Q&A panel. We'll address as many questions as possible at the end of the webinar. And if we have any questions left unanswered, we will answer them via the Databricks blog following up this webinar. So for those of you who are not familiar with who we are at Databricks, our company was founded by the original creators of Apache Spark almost 7 years ago. And our mission is to help data teams solve the world's toughest problems. Lots of people recognize us as the creators and founders of some of the best of breed open source technologies, starting with Spark, which was the first unified engine for processing both big data and machine learning, and has become the de facto open source standard in the industry. And more recently, Delta Lake, a storage layer that sits on top of your existing data lakes and brings performance and reliability to your data lakes. MLflow, an open source platform to manage the complete machine learning lifecycle. And Koalas, a new framework that allows to quickly Sparkify Pandas code, which will be the focus of our webinar today. Besides our rapid pace of innovation and commitment to open source technologies, what really differentiates us is our ability to truly unify various data analytics workloads and technologies on the Databricks platform to truly help our customers accelerate innovation. So you don't have to worry about DevOps so much, and you can instead focus your time and effort on delivering results that matter the most to your business. Our platform is built on top of Apache Spark, Delta Lake, MLflow, and much more. Here's a very simple diagram to show you what the Databricks Unified Data Analytics Platform can provide data engineers, data scientists, ML engineers, and data analysts with. First is the Enterprise Cloud Service. Databricks is a multi-cloud native service available on both Azure and AWS. It securely integrates with your cloud ecosystem, eliminating significant infrastructure complexity since it manages clusters under the hood for you. Next is the Unified Data Service built on top of Spark and Delta Lake. The goal of the data layer is to help prep all of your data, structured, unstructured, batch and streaming, in an open data lake for further downstream analytics, all types of analytics. Finally, the data science workspace is where teams can collaborate on all data and analytics workloads and be more productive. From ETL to models training and deployment, using familiar tools, languages, and skills via collaborative notebooks and APIs. In today's webinar, we will specifically focus on how Virgin Hyperloop One uses Koalas and MLflow on Databricks to discover insights faster. So I'm very pleased to introduce our speakers today, Patrick Olenyuk and Ifan Chow. Patrick is a data engineer at Virgin Hyperloop One, a company building the fifth mode of transportation. Previously, he was at CERN, where he wrote test software for the world's biggest particle accelerator, National Instruments, and Samsung R&D. He graduated from the EPFL, Swiss Federal Polytechnic in Lausanne, with an information technologies major. When he isn't glued to a computer screen, he spends time road tripping California with his friends. Ifan Chow is a senior product manager at Databricks. His product area spans machine learning, deep learning algorithms, and the Databricks runtime for machine learning. Prior to Databricks, Ifan worked on 2 machine learning products, applying natural language processing to find metadata and applying machine learning to predict equipment failures. Ifan started his career as a researcher in quantum computing and received his bachelor degree in UC Berkeley and master from MIT. So with no further ado, I'll now pass over the mic over to our speakers, Patrick and Ifan. Take it away.
Hi, everybody. My name is Patrick. I'm a software engineer at Virgin Hyperloop One. And today we'll be talking about what do we use Databricks for, what is our data. We're going to explore what do we use Koalas for. It's a great open source project. We're going to go through 2 live demos, including Koalas and MLflow. And at the end, because we've been early adopters of Koalas, we have a lot of tips and tricks share with you. So we at Hyperloop are around 250, 300 employees. We are based in Los Angeles. We are building Hyperloop, a new transportation system based on a vacuum tube and small passengers or cargo vehicles we call pods. And the pods are moving through the vacuum tube using electric levitation and propulsion. And the system is on demand. So imagine a mix of a train, a plane, and kind of an Uber. So because of all that, we can provide short travel times. And this system, we are already testing it. We have a 500-meter test track in Nevada desert built already in 2017. And the new exciting test tracks and enhancements to the system are in progress right now. So please check us out. We are also hiring. I work at machine intelligence and analytics team at Hyperloop here. We are around 10 people and we do operational research for Hyperloop. We provide analytics products for our business people and hardware and software engineers. We work mostly with simulation and data, and we try to answer questions like optimal vehicle capacity. And let's say we have that optimal vehicle capacity. How many passengers can we realistically handle in that day between a group of cities? And then if we know how many passengers, how much better are we than other modes of transportation? We get all these answers using data. So our example data flow would be to gather the demand data, where do people want to move and at what times for a given geography. Then we fit a Hyperloop track using geospatial data and using our 3D alignment optimizer. And for that Hyperloop track, we run our simulation that is planning the trips. And after the simulation, we already start seeing things like performance metrics and cost metrics. And usually something is wrong, and then we rerun the simulation, check if the data is right, sweep some parameters, and after a month or two, we have our analysis for a given region. And in 2019, our data sizes started to grow from megabytes to gigabytes, and our Python scripts based on Pandas were out of memory, or they were just running for hours. And we really needed some enterprise and more scalable approach to handling our data. We tried different open source solutions, and we discovered Spark. Spark is de facto standard solution. A lot of companies are using it. It's open source. It has so many different connectors to different open source libraries, databases, and that's great. We were going with Spark, and we didn't really have enough DevOps people to handle it. So this is already where Databricks comes into mind. And that's cool. You know, we are going to have all these Spark drivers, Spark workers. Our code is never going to crash again, hopefully, because we are going to distribute our workloads and use S3 and Hadoop. But then we also realized, well, all our code base is written in Pandas, and Spark is either using PySpark or Scala. And well, we weren't really keen on translating all the Pandas code, tons of lines of Pandas code into PySpark, and especially me after learning, I was learning that I was looking for solutions, and so that happened around in our April-May 2019, and well, that's exactly when Koalas package got introduced to the open source family. So I will let Yifan now speak about Koalas.
Great, thank you, Patrick. My name is Yifan Cao. I'm a product manager at Databricks. I focus on serving our data science and machine learning users. The pain point Patrick just described was exactly why we introduced Koalas to the open source community. Databricks has tens of thousands of enterprise data scientists working on our platform. While these data scientists work in many different industries, we actually notice they have a very common journey as a data scientist. That is, when they were learning about data science in school, they mostly work with small data sets and pandas and NumPy packages. But once they get a job and move into the industry, a lot of these data science find out that they would often have to work with big data sets. And thus we had to learn about Spark and distributed system. It is very similar to what Patrick and his team had discovered. Spark in Python or PySpark has a very different sets of API compared to a single node Python packages such as Pandas. Therefore, there's quite a bit of learning curve for these data scientists. This then led us to Koalas. Koalas' goal is to offer a new framework that combines the benefits of both Pandas and Spark. Pandas is a de facto standard for single machine data scientists and work well on small data sets, while Spark is a standard for distributed data processing and work well on big data sets. By combining the two, these data scientists should have a much easier learning curve when they have to work with big data sets, so they can deliver greater value much faster to their organization. So what is Koalas? We introduced Koalas last April as an open source project. Koalas, which we consider a cuter version of Pandas, it unifies the two ecosystems by offering the Pandas API on top of Apache Spark. Our vision with Koalas really is data science that can now seamlessly transition between big and small data sets while needing to know only one set of API, which will be the Pandas API. Now I'm going to give some examples of how that works. Okay, here are the code examples. This is an example Patrick showed earlier. On the left-hand side, I have a Pandas data frame. What I want to do here is I want to sum up the trip counts by destination and then display the top 10 destinations. However, if I'm working with big data sets, the Pandas data frame may not be sufficient. The data set may be too large to fit in memory of a single machine, like Patrick mentioned. Sometimes maybe also too slow to process. If I choose to use PySpark, which works great on big data sets, I would have to learn a new set of API. As you can see in the middle column, these API look very different from my Pandas code. With Koalas, which I can apply the exact same Pandas API to a Koalas data frame, which is distributed. Without making any code changes, now I can apply my code base to a much bigger data set. So how do things work under the hood? I'm going to show you, this is a Koalas architecture. Koalas is basically built on top of Spark. It inherits features and performance optimization from Spark. For example, the ongoing improvement we're making to Spark, such as the upcoming Spark 3.0 features, all of that will be also available in Koalas. In fact, you can even apply some Spark functions to Koalas data frames. They could make your life easier when working in a distributed setting. In fact, Patrick will actually discuss some of these best practices later on in his demo. On top of Spark, we add this thin API layer that mirrors exactly the Pandas API. That creates Koalas. To ensure good performance, we designed the API layer to be lean so that the overhead between Koalas and Spark is minimal. Ultimately, what we want Koalas to do is we want Koalas to bring out the best of both worlds. It combines the ease of use of Pandas with the scalability of Spark in one single framework. Since we introduced Koalas, we're very encouraged that we have seen our vision has resonated well with the community. We announced the project last April, and we saw significant interest both in terms of open source contribution and adoption. We have made more than 860 patches just under a year, and we have seen more than 20 major contributors outside of Databricks actively contributing to the Koalas project. As of last week, we have almost 25,000 daily downloads in PyPy. The bottom right chart is the daily downloads of Koalas in PyPy. So we want to thank everyone for your continued support. We'll continue to make Koalas better for the data community. Now I'll hand it back to Patrick.
So as Yifan said, Koalas allowed us to seamlessly switch from Pandas to Spark. And well, how seamless, we're gonna discover a few caveats in demo 1, but it really means that we can now scale our Spark workers. So if tomorrow our data grows from gigabytes to hundreds of gigabytes, we can easily increase the Spark workers and, well, have our processing times being seconds and minutes, not hours, and our machine won't crash. And obviously it comes with a dollar price, and you know, you also cannot increase your Spark workers to thousands or hundreds of thousands and expect sub-second processing times, because there is cost of distribution of the work from the driver to the workers and from the workers to the driver. So now let's see how to use Koalas. But before that, I want to show you the Databricks environment. So here I prepared on the left a Koalas cluster that is actually a pretty big Spark cluster with, I think, 20 or 40 Spark workers. And here on the right, I have a Pandas cluster. It's a single machine with 16 gigabytes of RAMs and 8 cores. So this is more or less like a powerful laptop. And I can already tell you that some scripts in Pandas are going to fail, especially on this machine and on smaller machines. This is a notebook, Databricks notebooks. It works exactly like Jupyter notebook. It's very convenient, and overall the Databricks environment, it's looking like this, and this is how you use it. So let's import Koalas. How do you import Koalas? How do you use it? You pip install it like any other package. It's open source, and then you import Databricks.koalas as KS or whatever you want. Both of these notebooks are going to be almost exactly the same. I just wanted to show you guys on the left Koalas and on the right Pandas, you know, just a comparison of what can you do with Koalas and what can you do with Pandas, and why it's worth it. About the data we are going to be analyzing today, we're going to analyze open source data from BART, Bay Area Rapid Transit. BART is a metro train connecting Bay Area cities. And the cool thing about it is that they provide open source data sets of ride-street patterns. And for those of you who would like to try it out by themselves, I included here in both of the notebooks a script that will download it into your temp folder or whatever folder of choice. So let's already start using Koalas. And while it's computing, let's see what's inside our data. So the data set tells us here, row by row, that January 1st, 2019, this is New Year's Eve actually, from midnight to 1 a.m., there were 4 people traveling from the 12th Street to 16th Street, and so on and so on. And this data set, these rows are repeated for all the hours in the year and for all the origin destination pairs. And because there are 47, I think, around 47 origins and 47 destinations, that gives us around 2,000 origin and destination pairs. And this is why we have, I think, 10 million columns. So this is just the data for 1 year, 2019. And we can already see that this is 400 megabytes, but for Pandas, it's actually cool for 1 year. You know, it took 6 seconds to load it. And as you can see, Koalas with the same API also loaded it. It took a bit longer, but then let's see what's gonna happen when we have a bigger data set. So what I'm gonna do, I'm gonna load exactly the same data, but from 2011 to 2019, and that gives us eight years. That's gonna be a lot of rows. So I'm gonna start this Koalas job. And as you can see, it took 2 minutes for Pandas. And I can tell you, if I ran if I ran it on my laptop, it would actually crash. I tried it, and it just crashed my laptop because there are so many other things I'm running on my laptop. So we're already starting to be a bit memory constrained. And the cool part about Koalas, it will never fail. Here we're gonna see a significant, not very significant improvement in time. It's still gonna take, I think, above a minute, still faster than Pandas, just because for reading static files, each worker actually have to read all the files and just choose the data it's gonna store. So that's why for this particular example, loading from file, Koalas is not so much faster. But it definitely does not crash. One change, this cache operation, this is what Yifan already was telling about, and we're gonna discover it a bit later. I'm gonna tell what it's doing in the tips and tricks. Okay, looks like it's almost done. As you can see, the data looks exactly the same. Everything looks good. One thing you can already notice is here the year is 2015, and here the year is 2011. That is because the concat and the head operation work a bit differently in Koalas. And that's because in Pandas, everything is stored in a single memory as a blob of data. Whereas in Koalas, it's all stored in different workers. So you actually never know in what order you're going to get your data, and we're going to explore how to improve that later by using sort and when. And as you can see, this data is already big, 4 gigabytes. So what we're going to do now is explore what is the top origin and destination pair for the BART, for the 8-year BART dataset. And please take a look that the code here is exactly the same, both the Koalas code and the Pandas code. And here, Pandas computed this result in 22 seconds. And for Koalas, it only took 6 seconds to compute. And you can already see the benefit. Now, what I would like to see on the left is this trend. So while it's computing, I'm going to tell what it is. I'm grouping by date. And I would like to see average trip count for the day, and I'm using rolling mean for all the days in the year to see a yearly trend. And then I'm plotting it using dot plot method in Pandas to see it in Matplotlib. Now something went wrong here on the left. Well, and that's for the same reason we discussed before. Our data is not ordered. So one difference is we have to use the sort index method, index being the date, to order it. And let's see how it looks like when we order it. And now it looks exactly the same. You can see one difference, one small difference would be this showing the sample result by fraction. This is an automatic behavior of Koalas. It's just automatically sampling for us. We can turn that off or change the behavior in Koalas option. That's also going to be in tips and tricks later. As for data, there is a visible decrease, around 10% decrease here between 2017 and 2019. We believe that it's because there were all these ride-hailing services getting more and more popular, and also part increased prices. It's interesting. So this trend, now I'm going to save it into the into a variable, just so that to reuse it later. And you can see it took 8 seconds here for pandas. Let's see what will our koalas do. So did it really take 0.22 seconds to compute the whole trend? I can already tell you no. Since Koalas is using Spark for computations, it's using Spark's lazy evaluation. So now what's going to happen is Spark now knows the computational tree for trend, but unless we use the trend somewhere and need the values, it's not going to compute it. So if you want to see what's the computational tree, you can use a special function Koalas called explain, and that's just going to tell you physical plan what it's actually going to be doing inside. And then if we really want to compute it, then we can use 2 pandas and then use, let's say, head to see what's inside the trend. And now, as you can see, there are Spark jobs, and the trend is actually computing. There are these nuns here because we are using a rolling mean. So it just starts with nuns. Okay, so now a typical time series analysis would be to have a trendless data, to delete that trend from your data so you can analyze it and create some models. And that's exactly what we are going to do here, again, on the right and on the left. So let's do it. And if I do it, what we can see here is there is an error, an exception thrown at that line. And that's because Spark and Koalas does not allow operations on different data frames unless you turn that option on. And there are a few behaviors like this that Koalas authors are trying to prevent users from shooting themselves in the foot. So that's just an optimization that we can turn off. So let's turn it off by using this line. Let's turn it off. And now we can happily create our trendless data set. Again, you can use the explain method to actually see what's the computational plan, because it's actually not computed. It's only computed here when we use the plot. And I'm expecting something similar to here on the right. Of course, it's sampled data, so it's not full data. Let's see how it goes. Now, why I know it's normalized? Because the data actually goes from -10 to 20. Normally, the trip counts would go positive numbers from 0 to, let's say, a few thousands. And as you can see, we have very similar results. Again, sampled here. That's why I used the sample method on the right here in Pandas. So as for data analytics, just because we're going towards the end, I would like to show you the dependence on the hour and day of week for that data. And as you expect, there is definitely a demand dependence on the hour. And there is the morning rush hour and the evening rush hour visible in BART. And obviously during the weekend, the trips are lower, much lower than during the week. And again, all these are actually all these operations are actually exactly the same as in Pandas. So now going towards the end, let's plot a very cool 3D plot showing both day of week and hour in one plot using Plotly Express. And as you can see, the data is exactly the same on the left and on the right. Now about the differences. So here I'm just putting a Pandas data frame. Since I know it's Pandas, it's already sorted. What I have to do here is first I have to sort the values, and then I'm using two Pandas. I know this data frame is very small because I'm grouping by day of week and hour and taking the mean. Because of that, I'm safe. But I just want to show you a short experiment. What if I didn't sort it? As you can see, if I don't sort the data, my plot is garbage. So please be careful. Just be aware of the different principles, and we're gonna talk about it a bit more in tips and tricks. Now our Pandas notebook and Pandas demo 1 is finished, but I would like to tell you a bit more about additional features of Koalas. So let's say I'm using Koalas as a data scientist, and I would like to give my code to a data engineer or some PySpark expert, or the PySpark expert. You know, people want to use whatever they like. So you can really easily call on Koalas data frame to Spark, and then you have a PySpark data frame, and then you can use your magical PySpark tricks. So I'm able to select, let's say, hour. And then I'm able to come back from PySpark back to Koalas. And let's say I want head of that. And again, if I want to come back to Pandas, I can again call to Pandas. All these conversion functions are done very conveniently. So please use it. One additional shout out to Databricks, just because of this notebook. There is this very nice display function for PySpark Spark data frames. If you display a PySpark data frame, you're able to use their internal visualization tools and explore your data using a table or using different plots. Now, my next demo is about MLflow and Koalas playing together. But before I go into it, let me come back to my presentation and tell you a bit more what is MLflow. MLflow is an open source project, open source by Databricks. And it consists of 4 elements for sub-projects, tracking projects, models, and model registry. We're going to focus on tracking today. And tracking, MLflow tracking is a very nice way to record your experiment runs, to see your historical machine learning, and not only machine learning runs, by using a very nice API. So you can log parameters, you can run your model, you can log metrics, you can log the model, and then it's all saved in a very nice database with a very nice UI. So imagine you're sweeping your parameters for your machine learning model, and you would like to explore what are the optimal parameters. with MLflow, you can very easily log your models and explore that optimal values. And this is exactly what we are going to do in a moment. So for this BART data set, we can see that the trip count definitely depends on the hour and day of week. And we're going to try to create a simple machine learning model to predict the trip count. And usually what would happen on my single machine is I would have a set of sweep parameters, let's say 100, and I would train these machine learning models one by one, and then score them, and then select which result is the best, and then save that model and deploy it to production. The problem is that sometimes training machine learning models can take hours or days. And because of that, it would be nice if we could do it in parallel. And this is exactly what we're going to use Koalas for. So we're going to use Koalas dataframe.apply method to sweep and score our models in parallel using the Spark workers. So let's go towards the mode 2. So just fast what I'm doing here, I'm going to be using support vector regression. I'm going to first sample 20,000 rows from my trendless data set. And then I'm going to take 25% of test set and 75% of training set. And as you can see, we have 15K rows of training data and 5K rows of testing data. So that's easy. That's a typical machine learning preparation step. Now I would like to focus on this function that is going to train and score our support vector regression model. And already we can see we have some sweep parameters here, kernel, C, and epsilon. What I'm doing here, I am starting a run with the experiment ID that is the same as my experiment ID here. So I set up an experiment here in my Databricks environment with the same ID. I'm saying this is the run name. And before running my model, I'm logging the parameters. Then I am running this is the hard work. I'm running the SVR model and scoring it. And then I'm logging the model and logging the metric for that model. So if the metric is good, I can reuse that model using the other parts of MLflow, let's say, to deploy it. So let's see what's going to happen when I run that function with default parameters. In MLflow, you can already see that run. It's running. From my experience, it should run around 12 seconds. Okay, it's done. It took 13 seconds. So if I open that experiment, I can see the parameters. What is the metric for that parameter? And I can see our model saved here. So the model is very nicely pickled, and there is the conda YAML. Everything is prepared for deployment. So now, normally what I would do, and what I'm doing here in Pandas, I would run a big for loop that would sequentially run this function one by one. And that would take around 25 minutes for, let's say, this set of parameters. That's, I think, 110 runs. What we are going to do, we're going to create a data frame. And in that data frame, every row is going to represent a model run. So this is one run with kernel RBF and C 0.4 and epsilon. This is another run, and this is another run. And we're going to apply function row-wise. So in Pandas, what Pandas would do is it would just row by row run the function sequentially, and that would take, again, 25 minutes. However, for Koalas, since every row is independent, it's going to automatically be distributed among Spark workers. So some Spark workers are going to take first few, the other Spark workers are going to take the other rows. So well, let's do it. We have our Koalas data frame. That's what I did here. First, I created in a for loop, I just created a dictionary. And then based on that dictionary, I just created a Koalas data frame. So let's come back to our experiment. I would like to show different runs. So when I start running it, you're already able to see that there are 40 runs currently going, 91. So the runs are currently running in parallel. And so this is definitely not going to take 25 minutes. One explanation I want to say, I created a wrapper function here that takes the row, this row here, and just passes that row to the train and score SVR model function. And this is a notation of type hint in Python 3. It's very nice. And why I didn't create a Lambda function, that's because both PySpark UDFs and Koalas do not play super well with Lambdas. I could have created Lambdas, but there are some caveats, so be careful about using Lambdas. I would say it's a bit better to define that wrapper functions not in line. Okay, so we have our results here. Now, the cool part about MLflow is I have all these 111, I believe, runs. MLflow provides a very convenient way to compare all your runs. So here you can see all our 111 runs in a table above. You can as well see some plots below, and also some 3D plots. And you can already see this is our epsilon and C, and our region of interest is somewhere here. So either I promote the best model, which is going to be probably this one, to production directly, or I run another grid search around that area and explore more. If you have more than 2 input parameters, then there is also this parallel coordinates plot that you can very nicely utilize for ND plots. So that would be it for the demos. I hope you enjoyed. Now moving to Koalas tips and tricks. I can tell you from my experience, we've been using the package around 9 months now, that almost all popular Pandas operations are available in Koalas. Some parameters are missing, and if we are missing something, please set up an issue on Koalas GitHub, explain what you're missing. I did, I think, already 3 or 5 issues, and they got resolved within hours, days maximum. Some functionality, though, is chosen not to be implemented, and the easiest workaround is to use your Koalas data frame. You do 2 pandas, then you do whatever you want that you did before in pandas, and then if you're finished, you can come back to Koalas. For example, data frame.values, it's not implemented on purpose because that would indicate loading full data into the driver's memory. And imagine in your workers, each worker is, let's say, 5 gigabytes, filled with 5 gigabytes of data, and you have 20 workers. That would be a lot of data in a single driver's memory. That's why you should either sample or, well, prepare a very, very big driver. And if you know what you're doing, just use Koalas data frame.toPandas.values, and then well, if you know what you're doing, your machine will not crash. But be prepared for some big data on your machine. Also, be aware about different execution principles. There is the ordering issue, so you should take care of using sort values or sort index. You should be careful about the lazy evaluation of underlying Spark data frame. So things are running a bit differently. For example, group by works a bit differently. Group by apply has a different schema, and there is a bit different treatment of nonce. And about kdf.apply, I really like using that function for any distributed row-based job, including web scrapping. Imagine every row would be some API call, or some dictionary mapping, as well as the MLflow runs. So that then you have all the row-based function calls distributed among all the Spark workers. Last but not least, the caching function that I've been using also a lot, especially for exploratory data analysis. So because of the lazy evaluation principle, let's say we have our KS trendless data frame with pre-computed computational tree on the left here. So every time I call KS trendless.head, it would go from the source of the files, meaning the CSVs, then group by something, and at the end, it will have the results. So every time it will take probably a minute to compute all of it. But if I use .cache, it's a way of telling PySpark, hey, I'm gonna reuse that value. So when you compute it, please cache it for me. And then next time when you use it, it's gonna be cached and reused. So this behavior is very convenient for exploratory data analysis. So you're doing it usually with Jupyter notebooks with different cells. If you have one big PySpark or Koalas script, then probably it's going to be optimized for you. Yes. Now about Koalas options, there are different options. For example, compute operations on different frames. We used that already today. If you want a nice ordered head, please use that option, set it up to true. Then there is a sample ratio. So if you set it to 1.0, it's gonna not sample your results. It's gonna be exactly like in Pandas. Please use the documentation to see the full list of options. It's very straightforward, I would say. So I think now, Irfan, it's time for you to tell them about Koalas roadmap.
Yeah, thank you, Patrick, again for that very nice demos. I'm going to talk about a little bit of what is upcoming in Koalas. At Databricks, we do have a dedicated team working on Koalas. They work closely with open source contributors to continue to add and expand our Koalas coverage. The #1 feature request for Koalas has been just expanding the Pandas API to Koalas data frames. Currently, we have about 70% of the Pandas APIs work with Koalas data frames. About more than 90% of most used Pandas API work on Koalas data frames. And then we'll continue to expand the coverage of that. After the API coverage, there are 3 major things we're also working on with Koalas. First is an integration with more plotting packages. Currently, Koalas does support matplotlib, but we are looking to add support for other popular plotting libraries. The other thing is a deeper integration with NumPy ecosystem. We have already implemented the universal functions in NumPy to work with Koalas data frames, and we'll continue to expand the NumPy coverage. Last but not least, we're looking to publish more example notebooks, and especially notebooks and blog posts that talk about how to use some workarounds, how to use some best practice when you are using Koalas. Because as Patrick showed earlier, even though Koalas API are the same as Pandas API, you will be working in a distributed setting when you work with Koalas. So that behaves a little differently as when you're working in a single machine setting. So there are a few simple tricks and tips you can apply to make your work much more productive, like cache or use explain to debug. So we will continue to, we'll publish some of these example notebooks, and we'll publish these blog posts. So definitely stay tuned for that. Last but not least, I just want to say we're constantly looking for feedback. Please do voice your suggestion, as Patrick always does. and then in our Koalas GitHub page, and we do take those seriously. Thank you for it.
Thanks, Yifan. So as for conclusions for our presentation here, we are doing very cool stuff at Hyperloop. Please check us out. We are hiring. We are looking to expand from around 300 to around 400 by the end of the year. We have a lot of openings. Our collaboration with Databricks is a very, very lucky coincidence since Koalas got open source exactly when we needed it. It's an amazing partnership too. We are using Databricks more and more. And I hope today you learn a bit more about Spark, about Koalas, and about MLflow. As for next steps, I just saw there is a new webinar about Sparkifying your MATLAB scripts. So we also do have a lot of MATLAB scripts that are long running, and we are definitely interested in exploring that option with Databricks, and hopefully there is going to be another Koalas for MATLAB scripts. Let's see about that. And before we jump into the questions, I would like to share a few references and links that are probably also below this webinar. Definitely check out the Koalas documentation on GitHub. We also wrote a blog post with Databricks, I think last year, about how we are using Koalas, and that was a bit earlier in the stage. So a few things got fixed. And if you don't want to move to Spark and you're just interested, then feel free to check this blog post of my friend about how to make your Pandas script a bit better. Maybe you define some data types, and it would help you figure out how to make your Pandas script and not to crash.
Thank you both so much for this great presentation. Can you hear me?
Yes, sure. My pleasure. Yes, I can hear you, Cyrielle. Yes.
Awesome.
I don't know.
Okay, we're back online. Sorry. Okay, so before we open up for live Q&As, just in case people join late, the entire webinar is being recorded and will be made available shortly for replay on databricks.com. We will also send you a follow-up email with the notebooks, the presentation, and the recording and related resources. Okay, so you can continue to submit your questions via the Q&A panel. We got some questions during the presentation, so we'll address as many as we can right now. And if we have any questions left unanswered, we'll post answers on the Databricks blog. Okay, so our first question is, can we use Koalas with Spark locally on a laptop to take advantage of parallel processing?
And I'll answer that. Yes, definitely. That's how we started at Hyperloop. We just checked it out locally. The cool part of it is then you can, when your data grows, you can just use the same script on a cluster, on Databricks or any other Spark cluster.
Awesome. Thanks, Patrick. Is Koalas currently or planned to be integrated with NumPy, Seaborn, SciPy, etc.?
Yes, I can take this one. Yes, Koalas currently already has some integration with some of the functions in NumPy, and then also with Matplotlib for visualization. We are, as I talked about earlier, we are planning to expand the integration with NumPy to more functions. And also we're looking at integrating with other popular Python libraries for data scientists. And we are actively monitoring the feature requests from our users in the Koalas GitHub page. So definitely voice your needs and demands in the GitHub page.
Thanks, Yifan. Yeah, we had some questions about how to contribute. Would that be through GitHub?
Yes, so the Koalas GitHub page, there is a page on how you can contribute to that. So definitely take a look at that.
Awesome, thanks. So what is the Koalas performance hit versus the Bear PySpark?
Okay, I can take this one. The overhead between Koalas and Spark data frames is quite minimum. The primary overhead really comes from adding index in Koalas data frame, which the Spark data frames do not have. The Patrick and his team actually did a recent study and then some benchmark testing, and they published a blog post about this. that blog post shows that the overhead between Spark and Koalas data frames is significantly less than the overhead between Pandas and Koalas, up to almost 100x in some operations. We at the Databricks, we're also planning to publish some blogs on some of the best practices of converting or choosing between Koalas and PySpark data frames. So stay tuned for that.
Thanks, Ifan. Are there any operations you should never do in Koalas?
Yes, I can take that one. So what I discovered by actually using this data set, that you should, especially for big data sets, never use pivot or transpose. Use group by if possible, because this takes each row and makes it a column. And this is kind of like destructive for Spark under the hood. You can probably try to do it, and it is, I think, implemented. It's just very, very difficult for Spark. So maybe it's better to do it in Pandas using 2 Pandas and then do something, or figure out another solution like group by.
Yeah, actually, I'm going to add to Patrick that makes sense, Patrick. There are also other workarounds you can do using transpose by setting up the Koalas, certain settings in Koalas. We are going to talk about these in the upcoming blog post.
That's cool.
Awesome, thank you. Did you use Delta Lake with Koalas, or the Delta Lake storage for the data frames?
Yeah, so actually for this notebook and for this example, I just used static CSVs downloaded from the website. I could definitely use Delta and Delta Lake. In Koalas, there is actually a function called the read Delta and to Delta, which will do exactly that. And I actually expect it to be much faster than reading from the CSV. I just did that demo like this.
Thanks, Patrick. Ifan, is there anything else you'd like to add about Delta and Koalas?
Yeah, no, absolutely. To what Patrick said, you can definitely easily read and write a Delta Lake table from Koalas data frame. It's fairly straightforward.
Awesome. Okay, I think we have time for maybe one more question. So, are there other packages available with similar purpose, like Dask? And can you tell what's the difference? And did you use it too?
Yeah, sure. So we do know about Dask. I have a colleague, Sandhya, that actually used it a lot, and it probably would also work, especially on a single machine. We found out and we feel that Spark is more enterprise. It's widely used. Dask is it's used to speed up computation mostly on single machines. I'm not a Dask expert though, so I cannot really say. But the principle of Dask and Koalas is in general the same, to speed up Pandas scripts, to parallelize, but they're definitely different in detail because Spark is just so much bigger than just speeding up Pandas.
Yeah, just adding to what Patrick said, we definitely think Dask is a great technology, and at the same time, Spark is being around longer. There are more enterprise features with it. There's the Spark community has done a lot of work to optimize, especially the performance and scalability of Spark. I think those really come in the 10 or 12 years since Spark has been released. So they're definitely, Spark's definitely been around longer.
Awesome. Well, thank you both for your time, and thanks everyone for attending our webinar. It was a great session. Please don't forget to rate today's webinar, and if you want to continue to learn more, you can join us at the Spark and AI Summit. End of June in San Francisco. We'll have a lot more training, 2 days of training, 2 days of technical talks and sessions, including Koalas, Spark, Delta, MLflow, ML frameworks, and more. So yeah, let us know what you thought about this webinar. It's always helpful for us to understand what topics you're interested in, so it helps inform future webinars as well. And again, this webinar was recorded and will be available for replay on databricks.com very shortly. Expect an email from us with all of the content as well. If any of you want to get your hands on a free Databricks account, you can sign up for free at databricks.com/try for a community edition account or a 14-day full trial account as well. Thank you, everyone, and have a great day.